All right. So today, I would like to build a multi-level feedback queue simulator thing. I've been reading more of the Operating Systems 3Z Pieces book. Read chapter 8 recently. And yeah, I think this would be a great use of my time to do that. So, um, I'll probably go through the details as we go. I don't want to do it all at the start, but basic idea is, scheduling. You have a bunch of jobs that want to run on the CPU. They all want to run, but the CPU can only handle one job at a time or one process at a time. So the scheduler's job is to figure out, what who should run at any particular which process should run at any particular time. So that's the basic idea. And then there's a bunch of different types of schedulers. Multi-level feedback queue is like one of the ones that seem pretty good. And yeah, I have notes and stuff from the book, but this is the basic idea. You have a bunch of queues, each of them given a different priority value. So the top queues, quote unquote, top queues are the ones with the highest priority levels, and then you get further down the pecking order, you've got other queues with lower priority levels. So the idea is if a job is placed in a high priority queue and another job is placed in a lower priority queue, so job A versus job B. If A is in a high priority queue and B is in a low priority queue, A will run, A will be given CPU time, B will not run. So the idea is only the jobs in the highest non-empty priority queue will run, and everyone else will have to just twiddle their thumbs or whatever, right? And then the next rule is if two jobs A and B are in that same highest priority queue, if they're both in that highest queue, then A and B both run via a strategy called round robin, where basically each job A and B will basically get sort of a fixed amount of time to run, and then the other guy will get that same amount of fixed time to run, and then it'll flip back and forth. So I guess if I had to draw it, it'd be something like A runs for a certain amount of time, and then B runs for a certain amount of time, and then A runs for a certain amount of time, and then B runs for a certain. So this is A, B, A, B. This duration of time in here is called a time slice, right? And the idea is it's an equal amount of time until A and B both finish. And it doesn't matter if A could be a very short job and finish after only 4 time slices, and then in that case B would just be left, and then B would just run because it's the only job left, kind of thing. But the idea is the duration of each job doesn't matter. In fact, it can't matter because the CPU or the scheduler doesn't really have any way of knowing how long a job will go for. Rule 3 is when a job arrives, it is placed in the highest queue. So a new job that arrives on the system, like for example, if a user punches in an executable to run it, and that executable, that process arrives on the system, it is placed in the highest queue straight off the bat. No nonsense. That way, it definitely has some chance to run because it's put in the highest queue straight away. And then you have this idea of once a job uses up its allotment time, it needs to be moved down a queue. So what does that mean? An allotment is basically it's a duration of time that a job can run on the CPU for. So, and it's typically, I think, it's generally greater than or equal to a time slice. In basic implementations, it's equal to the time slice, but it can also be bigger, maybe a multiple of time slice. So for example, let's say time slice is equal to 5 seconds or something. I mean, well, that's kind of 1 second. Even that's too long, but let's say a time slice is 1 second, and let's say the allotment period is chosen to be 2 seconds, right? Double the time. So what the idea is, let's say A and B both arrive sort of onto the system, they're both placed in the highest queue. A will run for a second, then it'll switch to B, right? Because of the time slice, the round robin stuff, B will go for a second. Then A will go for a second. And since A has now run for 2 seconds in total, it's used 2 seconds of CPU time, it will drop. It will be dropped to the next queue. Now, this is Q3 with the highest priority. It will be dropped to Q2. Maybe I should draw it here. It will be dropped down here somewhere, right? And then B will go again for another time slice, for another second, and then it's used its 2 seconds of allotment time, so it will also be dropped down here somewhere, is the idea, okay? So that's the idea of allotment. And then, like, why is that the case? What is the whole point of that? Well, the idea is this scheduler, and maybe schedulers in general, well, I don't know about that, but definitely this scheduler, it wants to make sure that interactive jobs need to be put in the higher priority queue. Higher priority queue. Because an interactive job, what is an interactive job? Interactive jobs are generally ones that relinquish the use of the CPU more often. Because, for example, if you make an I/O request, right, a request to a file or a request for user input or whatever, you're going to relinquish the use of CPU while you wait for that input output request to be fulfilled, right? You know, for example, if you're going to be requesting for a file, then you're going to make a request to disk, and that's not a CPU thing exactly. The CPU might help make the request, but then you're not using the CPU at that point until that disk request is fulfilled. So in that sense, you're relinquishing the use of CPU. And we call it interactive job because generally you're sort of interacting with, I guess, the user or with files or whatever, I don't know, right? But interactive jobs need to be higher priority because you want them to be more responsive. You know, if you're going to be asking users for input and the user gives the input and then you don't run for a while because you're put into a low priority queue, that's pretty annoying for the user, right? They're expecting, okay, I punched in some input, now something should happen. But if an interactive job is put into a lower queue, then all of a sudden it's like, well, what are we doing? Like, why is it taking so long to come back to the CPU? So interactive jobs, we want to put them in the highest queue. And the idea is, if you're making a lot of I/O requests and relinquishing CPU, it takes longer for you as a job to use your allotment time, right? Like, let's say, just as an example, a particular job runs on the CPU for a bit of time and then makes an I/O request. And then, you know, this is me like ignoring the whole round robin stuff. Let's just pretend there's just one job. Then it does a little bit more stuff on the CPU, and then it makes another I/O request. So red means this is a single job, but blue is CPU, and then red is I/O. I wrote cup instead of CPU. Very well done. And you know, the idea is allotment time only refers to your CPU time. So let's say only at this point do you use up your allotment time. So after this much time, you'll be dropped to a lower priority. But, you know, that's a decent chunk of time, you know. Whereas for what we call a more CPU intensive job, these guys need to be put in lower priority queue because these guys aren't as interactive, so the user doesn't necessarily have to deal with them so upfront the way that they have to deal with interactive jobs. So if CPU jobs kind of don't get all the CPU time in the world because they're put into lower priority queues, then that's not a big deal, is the idea. And the idea is, if a CPU job gets put into the topmost queue when it arrives, right, because of rule 3, it will use up its allotment time much faster and they get dropped much faster. So, you know, the interactive job took this much time to get dropped because it only used its allotment time across, you know, this much time of this much duration. Whereas in a CPU intensive job, will run for this long on the highest priority before it gets dropped. Because it's allotment time, the idea is this width is meant to be equal to these widths, like the sum of these widths. Because the allotment time got used up, but it took much less time for the allotment time to get used up for the CPU intensive job, and so it get dropped, and that's what we want, is the idea. Now, the final piece of the puzzle is rule 5, which says after some period of time, S is what it's called in the book, after some period of time, all the jobs get moved back to the top queue. There's a couple of reasons for this. One is because if the CPU intensive job just stays in the lowest priority queue, it is possible for interactive jobs to dominate on the CPU and for these CPU intensive jobs to never run, right? Like genuinely get 0 CPU time. If you have enough interactive jobs running and taking up the higher priority queues and round robining, across all of them, it's possible for the CPU intensive job to like never get a shot. So moving everyone up to the highest priority queue from time to time, every S seconds or whatever, means that at least a little bit of this job will get done due to the round robin and until it uses its allotment time. Then at least some progress is made. The other reason, what is the other reason? I've forgotten now. The other reason has something to do with so far I've been categorizing jobs as either interactive or CPU intensive, but certain jobs might be a bit of both, right? They might be CPU intensive for a period of time and then interactive for a while. So you kind of want this mechanism of, okay, this CPU intensive job was on the bottom queue for a while, but all of a sudden it's being interactive. So without this fifth rule, that job would just stay on the bottom, even though it's turned into an interactive process. And so it deserves more responsiveness, basically. It deserves a bit more CPU time. But if we didn't have that fifth mechanism, then these first 4 rules say nothing about bringing jobs back to the top. So that would be that job would be kind of screwed. It would be stuck on the bottom and maybe never have any responsiveness. So from time to time, every S seconds, every S milliseconds, whatever, all the jobs get put up to the top, sort of as a chance for that job to prove itself as an interactive job, even if previously it had been a CPU intensive job. So that's basically the theory. I don't know if there's much else. I guess if you go through the actual chapter, I would recommend it. If you go through the actual chapter, you get a lot more motivation behind the rules. Like they talk about things like avoiding gaming the CPU, which is like when a user writes a program that purposely relinquishes CPU from time to time in order to like make it seem more interactive than it is, and like so it stays on the top queue. It goes through some examples to make things more clear, and like it's a good chapter. It's a nice chapter, but I think that's a decent overview. So the main 2 bits of theory, like bits of terminology to remember, is like time slice and allotment. Time slice is to do with the round robin, whereas allotment is to do with how much time can pass on the CPU before you get dropped. And I think the only other thing I'd talk about is just mentioning the sort of hyperparameters that are involved in this kind of project or in this particular thing. Basically, the number of queues is a hyperparameter. How many queues you use is just something that you have to kind of guess and check kind of thing. Or, well, with experience, you don't have to guess as much. But, for me, I'm just going to be punching in random numbers and hoping for the best. So number of queues is a hyperparameter. Time slice, how long someone runs in terms of the round robin thing, that is a hyperparameter. Allotment size is also a hyperparameter. How long you can run on the CPU before you get dropped is a hyperparameter. And how often the jobs are boosted, that is how often the value of that S value, how often the duration of the period before you get pushed back to the top queue is also a hyperparameter. And then the last little thing that's mentioned is time slice is often varied across the queues. So time slice being that round robin idea. For the top queues with the interactive jobs, normally the time slice is very small because the idea is you have a bunch of jobs that are continuously relinquishing CPU time. So there's not much point in giving them large time slices because a lot of that time slice is going to be them just waiting for the IO request to be fulfilled. So you might as well keep the time slice quite small. Whereas for low priority jobs in the lower queues, the CPU intensive jobs, since they take since they're like running and doing CPU stuff for longer, it makes sense to give them a bigger time slice because they'll actually use that time slice to do things on the CPU. So that's cool. I feel like I forgot. I think also the allotment time can also be varied. I don't know if it. Did I say that anywhere? I'm fairly sure somewhere in the chapter it talks about how allotment time can also be varied, but I don't seem to have written that down, which is a bit strange. Give me a sec. Who knows? But I think that's a thing. I'm like pretty confident that I read that somewhere. I can't remember where I read it, but I'm pretty sure I read it in the chapter somewhere. I'll find it and confirm. But for now, I'm going to say that, yeah. Also, you can vary your time slices, but also you can vary the allotment time. That's like a typical thing, implementation detail. Did I talk about turnaround time? It's fine. I don't think that's... As long as these 5 rules make sense, that's like a major thing. Turnaround time is just a metric that gets used to evaluate how good the scheduler is. But that's not a big deal. Okay, so I have a little bit of a plan. It involves trying to be clever, which is always a bit worrying, but that's all right. So yeah, input we've discussed, variable number of queues, associated time slice value. Each queue is given an associated time slice value. Each queue is given an allotment value equal to or bigger than time slice typically, because it wouldn't make sense if your allotment was smaller than the time slice. Like you're saying the time slice is supposed to say, okay, you get to run for this amount of time before you switch. But then also, actually, never mind, because the allotment time is smaller, I'm going to drop you before you finish your time slice. So that seems a bit strange. So I think I'll try and enforce the rule that, yeah, allotment size should be bigger than or equal to. I would almost want to say it should be a multiple of the time slice. I'm not sure if that's strictly true. That didn't say, it didn't say that in the chapter, I think. So I wouldn't enforce that, but it would make sense because for a similar reason, like if if the allotment is not a multiple, like let's say the allotment, whoops, if the allotment is like 3 seconds, but the time slice is 2 seconds, and you have 2 jobs, like A runs for 2 seconds, and then B runs for 2 seconds. Let's say just completely on the CPU. A runs for 1 second, and then it's supposed to have this extra second to run for the time slice, but it's used up its allotment time, so I guess it gets dropped. It just feels a bit silly to do it like that. So I feel like allotment should be a multiple, because if it was 4, for example, then yeah, when it finishes a time slice, that's when it would use up its allotment time. But whatever. Maybe that's not even strictly true, to be honest, because when you do make an IO request, the allotment time doesn't get counted. So anyway, maybe that's not as important as I thought. Anyway, for now, I think what I'll do is I'll make it so that you can choose a number of queues. You can choose as time slice value and an allotment time value for one particular one value for time slice and allotment. So all the queues get one time slice value and all the queues get one allotment size. I just think that it'd be a good, I don't think it'd be that much harder to go and give every queue its own individual value, but for now, I think just for sake of simplicity, we'll keep it as one value, and then hopefully we can extend the system. And then S value as well. Job describing arrival. What? Oh yeah, I kind of started writing stuff and then I stopped, so I don't know what this is about. But let me get rid of that. I think what I want to do is I want to say I need to make a queue. So queues, I'm assuming, will just be linked lists. I feel that's the easiest way to implement this. Because you have easy access to the head, you can probably keep track of the tail, and then good stuff can happen from there. And then what? You want to basically say maybe keep the MLF queue will be an array of queues, maybe. right? So that you can keep track of all the queues. Maybe also it keeps track of the highest priority non-empty queue, because just again to clarify, you're always looking at the highest priority queue that is non-empty. So you might have 4 queues and you got this highest priority queue, but if it's empty, then this guy basically gets ignored and the jobs in here get run instead. So it's the highest priority non-empty queue that we're going to be mostly working with at any particular point in time. A queue is a linked list. Maybe you can also have a size field as well. So, oops, I wrote that wrong. Filed has a size field, so we can easily check if it's empty or not. MLF queue will have an array. Keep track of the highest priority non-empty. That seems like it would make sense. What else would I need? I guess I think with the interest of trying to extend this so we can have multiple time slice values, I think each queue should be given a time slice value and allotment value field. Allotment. Yeah, I spelled that right, I think. Like I said, for all the queues, they will have the same. They will all have the same value for now, but we'll just give them a separate. We'll give them their own field. MLF queue will be an array of queues. It will also field for the S value, that is the value that determines how often or the duration before everyone gets pushed back up to the top queue. Yeah, and then in terms of like functions, what do I need? That might be it for the structs. But for the functions, I'm gonna need an ability to. I have to think about I/O actually before I do this. How do I determine when I/O things happen? How do I determine when I/O things happen? Like, how do I simulate the I/O requests? I'm assuming it would have to be some kind of input. The user would say, maybe a point in time. It gives a list. It gives lists of points in time when that happens or something. Or I could do it like, maybe for now it's easier if I say like a frequency. So like every 3 seconds an IO happens, or every 4 seconds, or every 1 second, like every 1 unit of time, every 3 units of time IO happens. That might be a little bit easier. And actually, because of that, it probably makes sense. Oh, I have to tell. Yeah, I forgot a whole part of this, which is the job information. So like job information is the other part of the input that I need. So there's like the frequency of I/O, there's like the arrival time. At what point in time was the job actually submitted to the scheduler? The runtime. Oh, do I need to know that? Surely. Yeah, I think I would, because the idea is the scheduler shouldn't know this information, but I think I need to know this information. The scheduler shouldn't know the runtime, because a scheduler wouldn't know the runtime of a particular job, or it would only know when it arrived. It wouldn't know the frequency of the IO per job, because if it did, then it would know straight away if it's a CPU intensive or if it's a other one. It wouldn't have to do the whole allotment thing and checking the allotment and all that. Like, it wouldn't have to do any of that if it knew the frequency itself. But yeah, we'll do it like that for now. I think that's okay. I'm not sure. I think it'd be cooler if instead of giving a frequency, we gave like a list of numbers telling us when the IOs happened, because then it wouldn't have to be like a consistent thing. It could be like, yeah, because the in between jobs won't happen. In between jobs meaning jobs that aren't just CPU intensive or aren't just interactive. The ones that are a bit of both. You could be a bit more random with it, but anyway. Maybe we could use the pseudo-random libraries to try and like add some randomness, but I don't know. Probably not for now. Uh, yeah, I think that's enough job information. And then yeah, so that was, I think that's my inputs. And then structs, I have queues. I have the MLF queue, like the overall struct, and then also a job struct. I think would be good because like, so yeah, for arrival time, frequency of I/O, runtime. Yeah. Okay. So those are my structs, and then like in terms of functions, oh, it turns blue. That's pretty cool. These are my functions. So I need a way of course I have to pass my input, which isn't always annoying, but I always just assume that the input is perfect every time, which is terrible, but what can you do? Passing input, what else do I need? Like a way to like run a job for a time slice amount of time. Whoops, didn't mean to do that. Run a job for a bit of time. Check allotment of a job, like how much of the job, how much of the allotment time has the job used up. Like deal with IO request, which I feel like that's the one that's going to be really annoying for me to think about because that's the one that feels the most murky. Like, okay, I've decided that at this point in time, I'm going to do an IO request. I guess there'll be a constant, which is like duration of an IO request, which I'll make it. I don't think I'm going to make that input. I'll make that a constant for now. So deal with an IO request. So what would that consist of? It would basically be allotment time is paused. Time slice, I don't think is paused. Is not paused. I think the time slice still goes. Like it's still, yeah. I'm pretty from memory because round robin means like you get that whole time slice, which is again why time slices should be small for interactive jobs because otherwise you're just gonna be wasting time. But I think time slice is not paused. Allotment time is paused because you're not using the CPU anymore. And the idea is, yeah, the job is in a blocked state. Blocked state meaning, I'm waiting for the disk to do its thing or whatever. I'm waiting for the user input, so I can't do anything until that happens. So I'm in a blocked state as a job. But so I basically have to take. I think the easiest way to deal with that is to take it out of the queue. In fact, I might have a field like current queue field, so I can keep track of what queue you were in. And then job is in a block state, so I should like move it out of the queue and put it in a like blocked queue. I think I've seen this done before where it's like, yeah, if I don't want to keep it in the queue because I'm gonna get confused about I have to check, oh, are you blocked or are you good? Like there's a bit of extra bookkeeping I have to do if I do that. Rather, if I have a separate, I guess, queue, yeah. Oh, this is so strange. After a blocked queue, do I go second by? Is this a simulation that should go second by second? Like that feels like it's a bit much, but maybe that would be easiest because then like I just feel like I have to check like a lot of stuff. Are you still in the blocked queue? Is your allotment time up? Is your time slice up? Is your are you about to do an IO request? it might be easier to, I don't know, like I was hoping to like maybe go by time slice by time slice, and like every time slice we, go to the next job. And then also we can check the allotment time, especially if the allotment time is I think, yeah, maybe we will just run 1 unit of time. We'll see, we'll see. It feels like that would be very inefficient is the issue, but I also just, I don't know. It's easier to think about it if I'm just really dealing with 1 second at a time and just handling all the events that happen. But maybe I'm overcomplicating it. Maybe it's easier if I just go by time slice. Anyway, let's start with that. I think that's pretty good. So I have to, let's make our structs first. So I think that's so that I'm relatively comfortable with. Struct. I don't want to call it a priority queue because that's not what it is. It's a queue with priority. MLF queue queue. I'll just call it that. And so what did I say? It's a linked list. So it needs a time slice value. It needs an allotment size value. Maybe I'll just call it allotment. And then also it needs to have linked lists. So struct, what do I call it? Node. That's terrible. MLF queue node. And then let me type def real quick. Okay, so I need the job information, right? MLFQ job. So the job information is like arrival time, runtime, int, float, say int, frequency, and like, I don't know, somewhere between 1 to 10 or something. 10 is like every second of CPU, every sec, versus 1 is like maybe even 0. And then also, what else do I need? Job, where's job? Oh yeah, the current queue I'm in. Ooh. Maybe easier if I just give it as a pointer. Whoops. Because then you know the size of everything. So this should be above, I think. For alignment reasons. What have I done? This is for the node. Struct. So a particular node will have a job associated with it. Ah, of course. If I do this, yeah. No. Trying to get quicker, but I'm slow. And then the next node, MLFQ node next. Do I want doubly linked? Is it easier? Probably not, right? Because I only iterate. I only really care about what comes next. It should be like a circular list, I guess, because should it be circular? Yeah, I mean because oh no, not necessarily. Once you run it, you just put it in the back or something. Okay, whatever. Maybe there should be something like int CPU time left or something, like something to do with keeping, like in the job, keeping track of how much allotment time has been used. Int allotment usage kind of thing. That way, you know, I can be on the ball about when I should move it down. Yeah, and in terms of the queue, I need a head. So mlfq node head. So at the top, at the start of the queue, I have the associated time place value at the allotment. For a node, I have its job and also what comes next. Did I give a priority value? I did not. Int. Do I need to? Or is it better just to have... If I have these queues in an array, then I know that the head of the array, like the start of the array, has a higher one and the... Maybe I will, just for the sake of having it. Okay, so I have the structs, I think. I had queues, the overall struct, the MLF queue, which is like the main guy. Wait. MLF queue will be an array of queues. Oh, wait, and there's one more struct, sorry, yeah. So you got the queue and queue node, just like go hand in hand. This is the job, which is the individual details, and struct the actual MLF queue. I forgot about that. Which is basically MLFQ star MLFQQ. I did that wrong. So it's an array of that. Unless I want to do like hash define maximum number of queues. 100 or something. Apparently like 60 is a pretty good number, so I think 100 is fair. And then also the S value. I shouldn't call it S. Boost. Hang on. What did the book call it? Not better accounting. Or maybe it was, no, it was about rule 5. What did the book call it? The jump period. Period before jump. Time before jump. If I say const int, that means it can't be changed, right? Int time till jump. Again, if I go second by second, then that should be good, right? Then I should be able to decrement that. Decrements every second. When hits 0, all jobs in all queues get put into MLFQ. Wait, why did I call this MLFQ? All queues is what I meant to call it. When this hits 0, then and time till jump resets to time before jump. This is a terrible name. What should I call this? Time before jump? The between jump, between boost duration. time till boost. There you go. That's what I'll call it. Between boost duration. That's my S value. And then, yeah, okay. Nice. We have a start. It's always the hardest part about all of this. Starting. Whoa. Type def MLFQ becomes just MLFQ. Okay. So I have all this. What do I want to do first? Do I want to pretend that I passed the input successfully and just write all the other functions first, or do I want to pass the input straight away? I think I want to pretend that I have done the input. So IO request duration we'll say is like 10 or 5, no, 10. I think the book used 10 in one of the chapters. I'll use 10. Make my life easier. Okay, so let's pretend. What have I been given? I've been given a bunch of jobs, so I'll probably create a job array. So my proper input, like after I've dealt with the user input, my proper input will be an array of jobs, just all of them, just maybe sorted by arrival time. I think it'd be good to know which one comes first, arrives first, that is. I have a something else. I have my MLFQ struct, right? Contains empty queues which have in turn been given their priority value, time slice value, and allotment value. I think that might be it. The array of jobs and the MLFQ struct. What else would be given? You have the MLFQ, which is the scheduler, and you have the jobs. What more could you hope to ask for? Surely that's it, right? Like, I mean, to be fair, the MLFQ is like got everything: queues, priority values, time between boost duration. Like, it has all the information that you would have given. Jobs is like the separate thing that was also given by the user. Okay, so I think simulate MLFQ. This will be like the main, like this is the entry point, of course, of the program, but this will be like the actual, this will be like the actual thing. So you're going to be given a bunch of jobs. So MLFQ jobs array, and you're going to be given, I'm going to assume this is all on the stack. I'm just going to put that into the universe. MLFQ, this might not be on the stack. Maybe it will actually. This guy himself might be on the stack. Because like, I'll initialize it in the main, so it'll basically be like almost a static thing where like it just exists throughout the entire program, so it should be fine. I don't need to give pointers. But maybe I should. Actually, now I think about it. Because 4 bytes, 8 bytes. So maybe it is smart 6 bytes. That's already an address, that's fine. Okay. So we have the MLFQ and we have this. So the idea is, while we are still going, I don't know what the while condition should be. While there's still jobs, and maybe I should have a num jobs actually, now I think about it, because I don't know the size of the... I should also say int num queues over here, shouldn't I? Because I don't know how many, I don't know how big arrays are, unless I keep track of it. So yeah, bang, bang, bang. While we are still going, while, you know, so let's contemplate what the while condition should be. So the while condition will be something like, you know, still have jobs to arrive, still have jobs in the queues. Yeah, I feel like that's pretty much it. Maybe I need one more thing, like I might take in the Boolean, might steal the Boolean stuff. Is empty, like keeps track of whether there are any jobs in any queues, kind of thing. Would that be easy to keep track of though? I think so. I think it's better to be like, instead of is empty, int num jobs in here. The sum of all jobs, the number of jobs across all the queues. If that hits 0, then you know it's empty. And the idea is every time a new job arrives, it'll get put into a queue, so that will increment. Every time a job gets put in the block state or finishes, it will get removed from the queue. Block state as well, actually. So with the same MLF queue thing, I might also need struct blocked queue. Well, MLF queue node head in size, maybe? The idea being whoever got blocked first will also be the one who got, and then int, oh wait, hang on. I need to keep track of how long you have left in the block state, don't I? I can't do that here, I have to do that in here, or I have to make a new struct for blocked nodes. Should I just add a field in here, like int duration? I mean, what? That's so vague. Int time blocked, remaining blocked time. So that'll be 0 most of the time, but if it gets put in the block state, we'll set it to this constant, and then it'll decrement every second. So some functions will be, so what happens when a unit of time passes? Blocked jobs decrease by 1, like as in, no, that doesn't make sense. Blocked jobs pass for a second, or like a unit of time. Block jobs pass, time slice passes, check allotment afterwards. I just feel like this is not efficient to pass 1 unit of time, but I'm also worried, like, if I miss an event, then things will go out of whack. Like, if a block job has been unblocked, but I only realize after some, I don't know, I feel like it's just more accurate. Time slice passes, check the allotment afterwards. May have to drop a job. So yeah, block job passes a second. Oh, I feel like I've missed stuff, but I don't know what I would have missed. Time slice passes. Do we need to switch to the next job in the queue, round robin style? Also check allotment. Do we need to drop the job to the next queue? Do we need to boost all jobs back? That's rule 5. That's rule 4. That's rule 3. That's not really a rule, but that's kind of there. Ah, okay, of course. Has a job arrived? Put it in top queue. So this is rule 2, 3. This is rule 3. Block jobs are a thing. This is rule 2. Rule 1 will just sort of happen, I think. I don't think I have to worry about that too much. Also check the allotment. This is rule 4. And this is rule 5. Rule 1 is basically run the job that is find the top most non-empty queue and choose the first this is rule 1. Hang on. I'm a little bit concerned. I've been hit with a concern. If I have jobs in like the second queue, I'll draw this out. If I have 3 queues, let's say, and you have 2 jobs here and here, and they're running, right? A has run, and then a second passes. A is like halfway through the time slice. So this is the whole time slice for A, but A is only done like half of it. And there's another like half to go, right? This is meant to happen. But then maybe this is 1 second, and then this is another second, right? This is 1 second, this is another second. What if in this second, C arrives? C comes in and gets put in the topmost queue, in which case it's C that needs to run because this is now the topmost non-empty queue. So does A just kind of get ignored and then C starts to run? Is that the idea? I guess so. A just gets chopped off. So I guess what I have to say is put it in the top queue. Find the top. If this is the same queue as before, then keep going with the job you were running before. Like, for example, if we have A, B at the topmost queue, and then you have other queues here and here, and A is running, and then C arrives, then just keep working with A until it's done, then go to B, round robin, then go to C, time slice, time slice, time slice. But if we're in this other case, so if it's in the same queue as before, then keep going with the job you're running before. However, if otherwise, if the queue is higher than before, then stop whatever time slice you were doing and start working with this higher queue. And restart by working with this higher queue. I think this makes sense. I'm not 100% confident. I might have to do some extra checking as to what happens in this situation where, like, yeah, A and B are in like a queue, they're chilling, they're round robining, and then C arrives in the top more queue, in the higher queue. I don't know. Anyway, a blocked queue has this one. Do I want a size thing here? I'm just trying to think, like, the MLF queue talks about the priority value, the time slice value, and the allotment value. The blocked queue doesn't really have any of that. It just has stuff. To the point where, is this all I need? I guess maybe a queue size would also be good. But do I need anything else for the blocked queue? I just need to know. I just need to know when it comes unblocked, and then I can take this queue node and move it back to the queue that it should go to. Ah, maybe that's what I need. I need to know what queue it was in before. Int or MLF queue. Queue before blocked. So what queue are you in before you got blocked? It's probably a good idea, so that when you do get unblocked, I can put you back to where you were. Is the goal. Because the idea is, yeah, I think that makes sense. Has a job arrived? Figure out what queue we're looking at. Block jobs past a second. So if a job has been blocked, for, move it back to the queue it was in. Yes. Time slice passes, or increments or decrements, or maybe passes is fine. Well, the whole time is like 1 second of the time slice passes. Do we need to switch to the next job in the queue? Or what about, does the job do an IO request? If it does, then what happens? Yeah, if the job does an IO request, then if it does, like, put it in the blocked state. But does the for now I'm gonna say, well, to be fair, if I take it out of the queue, then it won't run anymore. Put it in the block state. Yeah, I think if I'm a bit. Okay, I think a natural consequence of how I'm writing this right now is when I put it in the block state, I'm taking it out of the MLF queue, right? So in that way, its time slice. Does it get like, what happens to its time slice? Does it stay where it is and get, like, held, and then when it comes back, it won't run for an entire new time slice, it will just run for that remaining time slice? Or does that time slice just, we just wipe the time slice, and then when it comes back, we'll just give it a fresh time slice? I think I want to say when it comes back, we will give it a fresh time slice. I think it would just be easier to write it like that, as opposed to like trying to keep track of how much of a time slice it had. Well, we might already do that actually. We have allotment usage, but we don't have a job's time slice usage. So maybe I need to give that as well. I have remaining block time here. So maybe here I can say int remaining time slice time. Slice time? How much of the time slice do you have left while round robining? How much time is left for your IO request? MLFQ start of one of these priority queues. The thing is, a priority queue is an actual thing, so I have to be careful. It's not an actual priority queue. It's just a queue that is characterized by a priority value. Okay, I think that's a pretty good start. I've been going for like an hour, and I think I have a decent plan, but it's also a little bit scary because I don't actually know what I'm doing. The thing I've mentioned a few doubts already, but I think if I just make a decision, I can write the code how I want. The one thing I'm a little bit unsure about is how I want to do the IO requests, like how to decide when an IO request has happened. Maybe I will. I think for now, what I'll do is I won't bother with any random stuff. I will just say, look, you consistently make an IO request every n seconds, given by your frequency value. So the smaller your frequency value, wait, no. Frequency, the higher frequency, the more IO you do. So maybe I should call it something else. I'll say not your frequency, but rather your, what, period? Yeah. IO period. Also, the name frequency is awful. That doesn't tell you anything. The IO period. Period meaning like how long between two particular IO requests. So, if you have a small IO period, so this should not be 0, it should be at least 1, and then you can say up to 10 or -1, meaning no IO requests if you want. Although maybe I'll say 0. I feel like negatives start making things weird. So the IO period is 1, then that means every second you're making an IO request. I think. You use 1 second of your time slice, you use 1 second of your allotment, and then you have you make an IO request. Versus 10 seconds means you're going to have to use 10 seconds of your time slice or 10 seconds of allotment before you even make an IO request, which means chances are you're going to get dropped very quickly, right? And 0 means kind of the same thing, except you really don't make any IO requests. Okay, I think that's pretty good. That's how I'll do it for now. Okay. So the while condition, while we still have jobs arriving, or we still have jobs in a queue, then while we're still going, I'll have like int current time is equal to 0, like a clock that keeps track of how much time has passed. Current time probably needs to increment. And then we need to say something like, what else do we have to say? We have to say, well, I had a whole plan, didn't I? Has a job arrived? Has the next job arrived? Which means I have to have a pointer pointing to I can't do anything until the first job arrives, right? So I might as well be like, look, next job is equal to jobs at 0. Wait, what? Why did I call it int? That's very strange to me. MLFQ job equals jobs at 0, right? And then the current time will just be the arrival time of that. Maybe current job? Next job is fine. Right? And then, yeah, I guess I say MLFQ, all queues, index 0, dot head. So queue size, okay, hang on. Void add job to queue given an MLFQ, given a particular queue and given a particular job address, or yeah, given those two things, can you add the job to the queue? So queue, I guess I want to keep track. I probably want the tail as well, so I can add things to the end. MLFQ tail, nope. Tail fair. Q tail dot or no, because that's also a pointer. Next is equal to this job that I'm going to be needing to make a node out of. So I'm probably going to have to malloc size of MLFQ node MLFQ Q node star node is equal to that. I don't have, yes I do. Node your job is equal to this job. Node your next is equal to null. Node your remaining block time is equal to 0, and your remaining slice time, I'm gonna say, is also equal to 0 because you're not running yet, I would think. Unless, I mean, now I should be careful because I have made the assumption that the tail is null. The tail is not null, sorry. So if qtail is not null, then qtail next is equal to this node. Else, qhead is equal to this node. Qtail is also equal to this node. Anything else I need to care about? Queue size should increment. Well, that should happen regardless, actually. Anything else? Your head has been set, your allotment is fixed, your priority value is fixed, your tail has been set. Ah, of course. Over here I should say your qtail next is equal to the node, and the qtail is equal to that node after you've done that, because of course the last node in the queue is now this guy as opposed to this guy. Okay, so you've set the tail, otherwise the head is the node, tail is the node, the queue, allotment, priority val, and time slice are all fixed. In fact, is it fair to be like const in places? You are a const or something, you are a const. You are a const. Is that fair game? I think it is from memory. NumQ is also going to be constant after you set it. This is const. This is not const because that will change over time. I think I'm using it correctly. I hope I'm using it correctly. Arrival time, runtime, IO period, allotment usage will change over time. That's variable. Okay, I think that's fair. I don't really use const that often. I'm trying to get better at being not bad. Why is this R? So if I add a job to a queue, I should say MLF queue, all queues index 0, right? Because the idea is, and then address, it's a pointer, so it's address. Nope, missed. And then the job that I care about, which is the next job's address. So I believe, because that should be void, right? So I believe I have successfully added that very first job to arrive. I've added it to the queue. I think. I can say something along the lines of printf time %d. I'll give an ID to I'll give an identifier to the job just so that I can easily identify who is who. Job %d arrives. So that's next job ID, and of course the current time. So in terms of I've done that, but I also want to probably start the running, right? Like in this point, current job gets added to the queue. Should I? Let's say this is this, like, let's say the arrival time is like 5. Let's say at this point we have started 5. And so when we increment and get to 6, we will say that current job, that next job, for example, that has just been added, has run for 1 second. So so what I think I have to do is say next job I just realized something. How do I know when a job is finished? I think this shouldn't be const. I think that should be... This is referring to like CPU runtime, total CPU runtime. That's just so I know, as like the programmer, I know when the job has ended, even if the MLFQ doesn't know that. So I have to be able to set the node value to be remaining slice time, remaining block time. So it's not blocked, it's got some slice time to work with. I think I need a pointer pointing to the one that's currently running. And then, yeah, I think that makes sense. I didn't think of that. But yeah, like, because the head is not... No, the head is the one that's always running. Sorry. The idea is when it's finished running, I'm going to put it to the tail. Yeah, sorry. I forgot how this works. No, I don't need that, because the head is the current running. So it has been set. When I put this as the head of the queue, that means this node is the guy that's running. Okay. I need to make sure I set, like, in terms of the NMLF queue, maybe it might be possible to talk about highest non-empty queue over here, so that I can easily look it up. So when I do all this, I can be like, add the job to the queue, and then MLF queue. What? highest non-empty queue is equal to the address of mlfq all queues index 0. Because I've just put that first job there, so good things happen. I just realized, I don't think I can increment this straight away. Because I have to look for like other jobs that are about to arrive. Like I could have 2 jobs that arrive at the same time. So I don't think it's fair to increment current time. I have to look for other jobs. In fact, if that's the case, yeah, I think I'll keep it like this for now. And then I'll just have like an integer job idx equals 1. Meaning, because we've processed job 0 already, so we'll start with job 1. So one of our while loop conditions will be like while job idx is less than num jobs, or mlfq. Wait, why did I delete the comments? Oh no, that's fine. That's still have jobs in the queue. Well, or mlfq num jobs is greater than 0. It's probably what I'll start with. The highest non-empty queue is that guy. Has the next job arrived? What else have I said? Has next job arrived? Find the highest non-empty queue. Head of the queue is currently running. Decrement 1 second from the time slice remaining field. If finished, put it to if the time slice is finished. If it's completely finished, if the job is completely finished, then remove from the queue completely and report. If the time slice has finished, then move the job to the back of the queue. If the job does an IO, move it to the blocked state queue thing. Should this happen first, actually? Should I prioritize an IO request before I prioritize everything else? Because, like, what if your last thing on the CPU that you do is an IO request, right? So that should happen first. Decrement 1 slice from time remaining and decrement 1 second from time left. Runtime. Okay. If the job is currently running, wait, what? If the job does an IO, move it to the block state queue. If the job is completely finished, move it out. If the time slice has finished, then move the job to the back of the queue. So we handle the guy who currently is running a little bit, and then we also have to make sure that I'm a little bit concerned about something else now, because I'm thinking about when you deal with this block jobs. So for all jobs in the block state, in that blocked queue, decrement time left in the block state. If it hits 0, the time left, if time left, then move the job back to the queue it was in before. Now, my concern is that here I would have had, a job that possibly does an IO request. And as soon as it does an IO request, I move it to the block state. But then once I move it to the block state, I decrement, which I don't think is fair because that job just got there. So I think I have to do U first. I have to say U first. I have to handle the block guys first, decrement the value, and then and only then do this so that if a new guy gets added to the blocked queue, then they won't reap the benefits of an unfair decrement over here. So I think this will happen first, and then this will happen. Yeah. Okay. 1 second of time slice passes. Does the job do an IO request? Did I write that already? Yeah. If it does, move it to the block state. When it comes back, we'll give it a fresh time slice. Yeah, with a fresh time slice. Also check allotment. Oh, of course, I forgot about that. If the time slice is finished, move it to the back of the queue. If a job is completely finished, if it's completely finished, yeah, move it to the end. If the allotment time is finished, move it down a queue all the way to the back. Move it to the back of the lower queue. That's what I meant to say. Decrement 1 second from the time slice, decrement 1 second from the runtime, decrement 1 second from allotment. Are we good? Okay, so that deals with the blocked guys, that deals with everyone else, and then what else? Ah, the boosting, of course. Final thing we have to do, decrement 1 from the boost thing. What's the field called? The time till boost. Wait, one of these shouldn't be const. Yeah, this shouldn't be const. If it hits 0, then go through every queue starting with the topmost non-empty, and move all nodes to the absolute topmost queue. What, in terms of whoever, the poor guy that was running, the poor guy that was running at the start, the poor guy who was running in the topmost non-empty queue will move to the topmost queue. Is he given is that job given a fresh time slice or what? Does the allotment time reset? Yeah, let's just say reset allotment count and time slice count for everybody. We just, it's like the lottery. Everyone's a winner. All right, we've been going for like an hour and a half or something. That's pretty good. That's a good start. This felt like a bit of an insurmountable thing at the start, but now I'm starting to feel a bit more of something, One more thing. Remind me how I'm planning on checking if someone has to do an IO request again. I know the frequency of the IO period that is. So I know how frequently it should be happening, but I actually have to keep track of how much time is left before the IO. So do I do it in here? Time till IO. And then, so when I malloc, because I create a node, don't I? Is equal to the job's IO period. Is that fair? Hopefully that's fine. So decrement 1 second from allotment, and if IO... Oh, wait, the 0 thing might be a bit dodgy. So maybe -1 is better. Because 0, I'm using 0 to mean it's time to do an IO request. If IO time left is not equal to -1, then decrement that. If the time hits 0, move it back to the fresh time slice, time till IO resets, allotment does not reset. If allotment reset, we'd have a big problem because the guy would never, for a job that does enough IO requests, it would never move down, which is a problem. Time till IO resets, allotment does not reset. Time slice resets, I'm saying. I think that's fine. I'm not really sure. Time till IO, slice time, blocked time. Remaining block time stays at 0, that's fine. Okay. Alright, I'll stop there for now. But I think that's a good plan. And hopefully if I fill out this template, we'll have a program that half works. Has the next job arrived? Is there any issue with doing that? Like, is there any reason why I shouldn't do that first? I think I should do it first because... Is it bad if I do it at the end? I'm just thinking maybe it's cleaner and easier because then it won't... Like, it won't change what the topmost queue is until the loop body is kind of at its end, I'm not sure if it's exactly clear which one happens first, so I'll maybe do this at the end. Run all the jobs. Yeah, I mean, something's got to happen first, so I don't know if it's a bad idea to make this happen at the end. So yeah, if I fill out this template, hopefully good things will happen. All right. Okay, and we're back. So off camera, I basically just try to do my best to fill out the template that we discussed. And I think I've done okay. Still haven't passed any input yet. I'm thinking of doing that now, but I'll just do a code. I'll just run through the code. and we can see if I've done anything silly. So major things is I did adjust the structs a little bit. I can't remember exactly what I had before, but I think MLFQ job is pretty much the same. But I think I might have moved a field around. Now it has an ID, an arrival time, a CPU runtime, and an IO period. Right, so identifier, when did it arrive, how long will it run for, how much CPU does it need in order to complete, and how long does it take for an IO to happen. MLFQ is the struct that I'm going to be using to be able to move, MLFQ nodes is what the queues will be storing, right? That's the element that the queues will be storing, so they will link to a job, an associated job. For every node, there will be an exactly one job that it's associated with, and next, because it's a linked list, singly linked list, current queue, so pointing to the queue that it's currently involved with is helpful in certain places, I think. I think I use that from time to time, occasionally. Or, yeah, this kind of thing. Maybe I won't need it. We'll see. Anyway, yeah. So current queue, just pointing to what queue you're in. That makes me think I haven't set that correctly. But anyway, queue before being blocked is also helpful. It's more helpful definitely because I use that a lot more, or I actually do use it. When I move a queue, when I move a node from the block state to the ready state, I know which queue to put it back in, wherever it had come from. And then also these values telling me, how close a particular job or node is to completing a certain thing. So time till I/O, how much time is left before the I/O happens. Remaining slice time, how much time is left before the time slice finishes. Remaining block time, if it's blocked, how much time is left for the blocked, and then allotment usage. Basically, how much of the allowed allotment time has it used, right? So those are helpful. Queue, I don't think I had this before, so this is more generic. I should really rename this to be something a bit more specific, but I have two types of queues. I have the MLF queue, just the normal queue that we've been talking about with the priority and everything, but there's also the blocked state queue, the blocked queue, which is like a queue that I'm using to store all the blocked jobs. So I need something a bit more generic. So queue has a head, has a tail, has a queue size. Nice and simple. Then there's an MLF queue, which stores one of these queues so that I have access to all of that functionality, but also keeps track of the actual priority value, the time slice value, and the allotment value. Right. Then the the major structure, the overarching structure is an MLFQ which has a array of MLFQ pointers. MLFQ queue pointers. So an array of that's about, if I have 10, 20, 30, 100 arrays, I can store all of them in a singular array. And the idea is the zero index of this array will store the zero priority, the one with the lowest priority. And on the other end, at n-1, that index, will store the address of the highest priority queue. So it's going to go like that. From left to right, it goes from low priority to high priority. This pointer will point to this will be the address of the highest non-empty queue. So I can the idea is if I can keep this accurately, if I can do my bookkeeping accurately, I can easily find the highest priority queue that is non-empty, and therefore I know, where the round robining should be happening. So it should be in this queue. Oops. Number of queues is a constant int, whatever the user sets it to. Between boost duration is that S value we talked about. Time till, and then these two metrics. These two metrics will be edited throughout the program. Time till the next boost tells us how much time is left before everything should be moved back up. And then int num jobs will be adjusted as new jobs arrive, and as jobs finish, that will be adjusted so that I know when to terminate, basically. And then we have a bunch of functions. I think it's easiest if I start from the high order function and then move from there. So I did change things around. Before I had tried to be a bit clever and figure out what my starting time would be based on the first job's arrival. I have to sort the jobs. I forgot to sort it. sort jobs by arrival time. I'll go do that as well. I forgot about that, but I'll do that now. But yeah, so now I'm just going to be a bit more simplistic and just start the current time at 0, start the first job ID, like the job index at 0, make my little blocked queue. Block queue, by the way, is just type deft. It's a queue. I just call it block queue. It's just one of these guys. Anyway, but I have a block queue which will let me store all the blocked state jobs. I initialize all its fields and stuff. Everything's empty. And then, yeah, while the job IDX is less than number of jobs, meaning that we have at least one more job that needs to arrive, or the MLFQ number of jobs in the actual, in all the queues, across all the queues, if the number of jobs is greater than 0, that tells me that this condition tells me that we probably need to keep going. There's some reason we have to keep going. Either there's another job that needs to arrive, or there's still jobs in the system that need to be completed. So we have 4 kind of overarching processes that I abstract away with functions. Basically, simulate the block processes first, then we simulate the running process, we simulate any boost, the priority boost, and then we finally check if anyone has arrived in the system, which maybe I can do as a function as well, but we'll see. So I think, yeah, it's good just to go through it in order. So simulate block process. Given the blocked queue, we're going to see, we'll see what happens. So we basically, all we do is we iterate through the queue, through that queue, through the linked list, and we just check, we decrement everybody's remaining block time. We decrement that by 1. And if it goes to 0 because of that decrement, then we remove from the queue, this blocked queue, we remove from the head, we remove the head from the queue, and we add that current to the end of the queue that it was in before it got blocked. So nice and simple. Something to bear in mind, I believe a condition or an invariant of the block queue is that the elements will be sorted in order of how much time it has left in the blocked state, because the guys who got put in earlier and therefore are near the head of the queue will have less time left, whereas the guys who came in later will have more time left and will be at the back of the queue. So I think it'll be sorted like that. So the people at any particular point in time, the jobs that are ready to come back will all be at the start of the queue. There won't be any places where, for some reason the head of the queue needs to stay, but then the guy after him has to go. Like that wouldn't happen. So, if there's anyone that needs to be removed from the queue because they're finished being blocked, they will all be at the very start. They'll be at the very start of the queue. So we can just, when I say remove from queue and I just give the block queue, all I'm doing is dequeuing the head because I know that it's the head that needs to be removed. So there's that. Then there's, add, so we remove from the block queue and then we add this particular node that's completed, its block time, we add it to the queue that it had been at before, and we just mentioned that the time till IO for this current current node, is going to be the IO period that the job is given, set by the user, and the remaining slice time is going to be the queue's set slice time slice. Fair enough. And then we move current along to the next. The reason why I couldn't do this as a for loop, or I couldn't just say current equals current next, I couldn't do this because basically, because the current node gets moved, potentially, due to the if statement, the current could get moved to another node. And if it does, to another queue. And if it does get moved to another queue, it gets added to the back, the end of the queue, in which case its next value, its next field will be set to null because it's the last thing in that queue. So if I did current equals current.next after the if statement ran, it would go to null. And then this would terminate and would terminate prematurely. So that's why I had to do this trick of getting it almost as a temporary variable, the next, before I run the if statement and then making current equal next. And that's why I did it as a while loop. But that's not super important. So that's the first thing. So just, simulating all the block processes, getting decrementing their sort of waiting time by 1 and going from there. Simulate the current running is sort of the meat of the process, of the program. So first things first, MLFQ, we look up the highest non-empty queue. Remember that this is meant to keep track of the highest priority queue that has stuff in it. So if it's null, then that indicates, okay, there must be no jobs in the system. Return. I could also say if number of jobs is equal to 0, which could happen, especially at the very, very start when nothing's arrived yet. If this is equal to 0, then return. Maybe I'll do that. Maybe that's a bit easier to read at least. Anyway, otherwise, if it's not equal to 0, then we have a good indication that there should be a highest priority queue, which I just extract that field and save it. And then I also get the actual queue. Remember that MLFQ queue stores a queue on top of the other information. So I have to actually, in order to access the actual queue, I have to access the field queue. In fact, this can say highest, whoops, my fingers were wrong, that's highest priority queue. And then out of everything in this particular queue, remember we run the guy at the head of the queue. That the guy at the head of the queue is the one that will be running, and we're pretty confident that this list has someone in it because, you know, highest non-empty queue is supposed to point to a queue that's non-empty. So we're pretty sure that I don't have to do any error checking, making sure it's not empty and stuff. So yeah, current running is the process that we're going to be running. And then I basically decrement all its fields. You know, I don't know if I have to do this. I think I might, just because of the way I've written it. I just double check that the value is greater than 0 before I decrement by 1. Right, so the time till IO decrements, the CPU runtime decrements, allotment usage decrements, and the remaining slice time decrements. Definitely for this one, I have to check if it's greater than 0 because a user might set this to be -1 for a particular job if they don't want any IO for that job. So definitely here I should check if it's greater than 0. All the others was more out of paranoia, but I just thought it's safe, so I might as well try. So yeah, so do all the decrementing first, and then first things first, if current running, I should do this before I do anything else. This is an error check. This should not happen. This should be a redundant error check, but if current running is null, then that's really bad. That means that the MLFQ highest priority queue thing, this guy, was empty when it should never be empty, right? It should either just be null if there's no jobs, or it should point to a non-empty highest priority queue. So yeah, error check, and then these decrements, and then I just do a print statement just to be like, look, this is what's happening, this is the job that's running. And then, yeah, I just go through each field, but I prioritize. I say, okay, if it's the time till 0, if it's the time till IO that's hit 0, then we'll move it to the block state, right? Else if the CPU runtime has completely finished, that indicates that the job has finished. And I basically remove from the queue, remove the head of the queue, which is current running. I remove the head of the queue, and then I free current running, because this is on the heap, I believe, and then num jobs of the MLFQ decrements, right? But notice how either this will happen or this will happen. Like, it's possible that both of them will happen at the same time. Both time till IO and CPU runtime will hit 0. But in that case, only the first branch will happen. The second branch, it's else if, the second branch won't happen. I think I want to do that because, for example, like if this happens and your time till IO hits 0, then you need to do your IO. In which case you haven't finished yet. I shouldn't mark you as finished. So I think that's why it was like, okay, do if and else if versus if and then another if statement. So else if this hits 0. So I prioritize the time till IO over the CPU runtime. And then else if allotment usage is equal to 0, that means I should remove from the current queue, this highest priority queue, and then I do this thing where I check if the priority value is equal to 0. That is, you're at the bottommost queue, like lowest priority queue. Then I basically just re-add you back to the same queue, but the back of the queue, as opposed to back to the front. Oops, back to the front. Your allotment usage resets, and your time slice resets as well. But it's as if like you didn't really get dropped. You're already at the lowest point, so you're just going to the back of the queue. Else, if you're not the lowest priority queue, if you're not in the lowest priority queue, then we figure out exactly we get your current queue index, because the idea is, remember that MLFQ has an array of queues. has all the queues, and the idea is your index in that array matches your priority value. So the high priority values are going to be on the right side in the high index range, and then the low priority queues are going to be on the left side of the array in the low index range. So here I'm just getting what index the current queue is, the high priority queue is, and then we get the next queue by subtracting 1 from that index and accessing the array. Then we add this current running to that next queue down, specifically its queue. And then we reset its allotment usage, but using the next queue down's allotment time, as opposed to the current queue, which is why it's different between this if versus this else. We're using the next queue down values to set the allotment usage and the remaining time slice. Else if the remaining slice time, I keep reading it wrong. If this remaining slice time equals 0, that means we just have to remove you from the queue and then add you back to the same queue, but the back of the queue. So we're removing you from the front and then adding you to the back of that queue. And then again, we reset your values. So notice how actually this line and this line is actually matching this line. Whoops, this line, this line, and this line. I was thinking I could make it a function, but it felt a little bit. I didn't mind it being the same because I kind of felt like it was. I don't know. Didn't feel like a big deal having the same lines twice here. Anyway, that's that whole function. And notice how, it's if, else if, else if, else if when I do these checks. Like, there's no, only one of them is going to happen. Sorry, as in, like, multiple might hit 0, but I'm only going to handle one of them. I'm prioritizing, time till I/O over CPU runtime, and I'm prioritizing CPU runtime over allotment usage, and I'm prioritizing allotment usage over remaining slice time. Because I think that makes sense. It's like if I already explained why I think this should happen first, but if your CPU runtime hits 0, there's no point putting you in another queue. There's no point doing all this stuff. Like, you're done. There's no need to do more, right? Plus, I'm going to be freeing you, so it would be really bad if I tried to run this other stuff. Else, if your allotment usage and your time slice usage both hit 0, like, I'm already putting you to the back of some queue. Why am I putting you to the back of a queue again, So, like, again, I think else if is fine. That should be fine. So that's pretty much that whole thing. Current running. Simulate boost, in comparison, is definitely simpler. I just time to a boost, I decrement by 1, and I figure out the highest queue. Sorry, no. This is the actual highest queue. So this is a little bit confusing because what I called highest queue over here was actually the highest queue that was not empty, right? Maybe I should call it highest. Oh, I gotta be careful, actually. Okay, just deal with the errors as they come. You good? Okay. So that's the highest. Whoa, that's the highest non-empty queue. But the highest queue is actually the highest, like, n-1 index, like highest queue, highest priority you can get. So we decrement this, get the highest queue. If time till boost. Actually, I don't have to do this unless. I don't have to do any of this unless this is true. So I might as well do this inside. So we decrement if this goes to 0, then we get the highest queue. Then we iterate through all of the queues, right? We iterate through all the queues and we move an entire queue we move this entire queue into the highest queue. So what does this do? So it's a helper. Basically, it goes through all the nodes in a particular queue, dequeues them, and enqueues them onto the highest queue, right? So, I generically say source and destination. I dequeue everything from the source and enqueue it into the destination. That's all this is supposed to do. Oh yeah, and for the same reason as before, I have to sort of do this temporary trick again. I can't do a for loop because the current will point to null after I add it to another queue. So same thing, I have to make it temporary. Anyway, but yeah, so I'm moving the entirety all the elements from one queue, and I'm enqueuing them onto, in this case, the highest queue, which is what I'm supposed to do due to this when this boosting happens. And then for the blocked nodes, notice how I pass both I pass the blocked queue as well. For the blocked nodes, I don't move them anywhere, but I set their queue before blocked to the highest queue. So when they do eventually run out of their blockage time and they are ready to come back, they will move back into the highest queue. They'll be given the chance to go back to the highest queue. They don't miss out just because they're blocked, you know. They'll be able to go back to the highest queue when they're ready. And then highest non-empty queue, like the MLF queue's highest non-empty queue field is pointed to the actual highest queue, the highest queue, and the time to a boost, of course, resets back to the between boost duration, which is given by the user. So that's that. And then finally, I just check if a job's arrived. You know, I use the job IDX. If the job IDX is equal to the current runtime, then that indicates that this job is going to arrive here. So I get the job, of course, incrementing the job IDX as I go. I don't use this anymore, right? Yeah. And then I add the job to the MLF queue. That's the function I think I wrote. I think I wrote that on camera, right? So that's fine. Basically, I take the highest queue. Remember rule. Oh, my OneNote's closed. Remember rule. I think it was rule 1 or something, or rule 3. Yeah, when a job arrives, it is placed in the highest queue. Add the job to this one, which means actually, now I think about it, if I'm going to do that, then my MLF queue highest non-empty queue should point at this guy, shouldn't it? All queues is an MLF queue double pointer. So when I index it, I'll get an MLF queue pointer. This guy is also an MLF queue pointer. Good. So then yeah, that should be fine. And this increments because I've added a new job to the system. Yeah. So there's definitely bugs. I haven't tested anything, but I'm sure, like, you know, there's one mistake here, and I'm sure there's a bunch of others, which we will find through time. But yeah, for the most part, I think I've basically done most of the comments. There was one thing though. What did I say? There was something I said I wanted to do. Oh, sorting. Sort the jobs. So I'll use the quick sort thing. So let me first make a comparison function. Int sort by arrival given void star job 1 void star job 2, and then I cast it. So MLFQ star job 1 casted is equal to this guy, job 1, and then MLFQ job star job 2c equals job 2. So we cast and we return. So what is it? If the first guy should be before the second guy, you should return -1, right? Or negative value, sorry. So jobs 1c arrival time minus job 2c arrival time. That should be it. And then I just have to say qsort given the base. No? qsort given the base, which I think is the array, given the size, which is num jobs, number of elements, and then the width. What? I don't remember this part. Width, I guess, is size of. Size t number of elements, size t width. I'll double check that, but I'm pretty sure that's what I'm going to do. Sort by arrival is the function. And let me just check how to use qsort in C. Yes, I know that one. Size of the bytes, yeah. Of each element? Yep. Good. Okay, fantastic. So we qsorted first so that I know that the array is, every time I iterate through the array, I'm going for the earliest job first, and then next earliest, next earliest, next earliest. So that should be good. It's kind of hard to test this without actually dealing with the input though. So I guess we do that now. But I think we've done well to execute a plan. There is definitely the efficiency issue where, like, I'm iterating second by second. I'm incrementing current time by 1. There's definitely a thing where I could sort of, using the numbers, predict what the next sort of important event will be. What's the next important event? Is it a blocked process that becomes unblocked? Is it a running process that gets blocked, or a running process that completes, or a running process that finishes allotment, or a running process that finishes its time slice? Is that the event? Is it a boost? Is that the next thing? What is the next event or events, what plural, that will happen? And then instead of incrementing current time by 1, I adjust current time to be that time when that specific event would happen, or those specific events would happen, and then deal with those events as they come. So that would be like the way to make it more efficient, but for now, I'm quite happy to just trudge my way through the time and just see what happens second by second. So that's fun. So for now, yeah, let me int argc, string I can use, right? Argv. String is from my string type thing, which gets included when I include my argparse thing, which I have built, and it seems to work okay, so I'm happy to use it. I have to first set everything though, so I need a parser, argparser star argparser init. I messed that up. I need to say parser equals that, and then no parameters, which we love. Eventually I have to free it, argparser free parser, so that'll happen at the end. And then I have to be like parser, and then what do I want to do? I want to say add, I guess, a flag. So given the parser, given this short option, which I'll call J, long option I'll call --J. Do I want to, we'll see. Default value is null, type is string, and the optional is false. It can't be optional. So I have that. I have, like, we'll say n, or maybe q, and wait, this should be long jobs. Num qs. How do you spell q? There you go. This is an integer type. False. Yep. Arg parser add flag. I need to give an allotment time -a allotment. Also int. Nope. Default value. We can give a default value 5. Oh wait, it has to be strings though, because everything's strings. This can also have a default value. We'll say 5 as well. Arg type is int, and optional is true because I'm giving a default. Oh, which means this is also true because I'm giving a default. Fantastic. Arg parser add flag. I need to give allotment time and also time slice. So -t time slice. Default, we can say is also 5. Is 5 too long? Should I say like 3? I don't really know what I'm doing. 3, and then type is also integer, and boolean optional is true. So I'm able to give the number of queues, I'm able to give the allotment size, the time slice size, I'm able to give the job information, well, I think. The S value. Arg parser add flag parser -s, or the boost between, it can't be too long. We'll just call it boost. Should I call it B for boost? The book used S for some reason, but I'm happy to call it B. It's an integer, and oh wait, no, default first. We'll say every 6 seconds, and then type is int, and it is optional because I gave a default. Okay, so yeah, so we have these flags. We're able to give the information, your boosting time, your time slice time, your allotment time, your number of queues, and you should be able to give in your job information. How do I want to structure this? So considering you have to give your arrival time, your run time, and your finish and your IO frequency or IO period time, I think what I'll do is I'll like do something like this: arrival time, run time, IO frequency time. So it'll be like ARF, comma A colon R colon F, etc. until A. This is kind of how I did it for these other things that I built, similar schedulers but less complex. So I think that's fine. Should be good, right? And that will help me determine how many jobs there are as well, because I'll base it off how many of these groups there are, comma separated groups. So that should be fun. No spaces though. If there are spaces, it will screw me over. Yeah, okay. So then after I have my options, I have to say arg parser pass. I tend to forget to use this function. Given argc and given argv. Once I was using my command line argument thing and I forgot to call this, and I kept having nulls for everything. I was very confused. Anyway, so we pass the actual argv and argc. We parg the actual argv, and then we can get all the values out now. I'll make a function to pass the job information and make the array. And I'll also so what is it? String to long? String to L? That's the one. Given a particular string, which would be parser, would be get arg parser get, given the parser given an arg name. So I need to get the number of queues given and get the actual value. So given that string, I need to get an end pointer. End pointer. Is it void? What did they say? Char star star. I think this is fine. And the base is base 10, and this will give me, and I'll pass this into an integer, and I'll say int numQs equals that. The whole point of the end pointer and stuff is to like error check this call in case something goes wrong, like if there's a passing error, if it didn't have any integers, whatever, like if there was no integers. Sorry, if the string didn't have had a non-digit in it, for example, or whatever, like if it was empty, I don't know if the string was empty, but I'm going to pretend that input is perfect 100% of the time and be done with it. So allotment size is equal to same thing, isn't it? So int this guy, but instead of this, we're going to use -a, and then time slice size, or time slice, let's call it allotment, time slice -t, and then boost period, whatever, maybe just boost, is equal to, oh my god, is equal to -b. So that should get me all my values that I need, which is cool. So in between all this, I need to pass the jobs, of course. And I also need to, and then after all this, I have to construct the MLFQ structure. Because remember, I need to make my array, I need to know how many jobs I have, and I need to make my structure, which should be fun. So let me pass jobs. We'll say int pass input jobs given what? The jobs as a string and maybe the array. So mlfq jobs as an array, and the user's input should be a string. So string the job input. So the idea is I'll make this on the stack so I don't have to free things. I'll be like mlfq job jobs, and I'll hash define some maximum. Max jobs, we'll say like, well, I said 100 queues, so I feel like 100 jobs would be like, yeah, screw it. Easier to change. So this guy equals, and we'll just, do I have to do that? Can I just declare it? It should be fine, right, if I just declare it? Okay, so we have all that. And the idea is we'll call pass input jobs function, and it should return the number of jobs. So int jobs equals pass the input jobs function given the array and given the parser -j value. Fantastic. Okay, so we have all this, which is fun. And then we can be like, what can we say? I have my string, I have to iterate, and the idea is, okay, so the way I like to do this is I have a head value, which points to the start of the input originally, and then for char star c equals the head, like start. It's not the null terminator, as per usual, and then we increment the pointer across. If this thing, so like we said, it will be colons and commas that separate the information. So if it's a colon, then what? I need to know if I'm reading an A, an R, or an F value. I should also have int num jobs equals 0. Do I need Boolean flags? Is that the idea? Int, okay, I'll do it as like arrival equals -1, int, maybe I'll use -2, because I actually, -1 means something else in my program. Runtime equals -2, int, it's not really F, is it? It's more period, IO period. So I'll just hash define that. Hash define onset -2. So what I do at this point is I set this to be the null terminator, and I read it in. So I say I use this function. Equals, and then the string I want is head, that is being null terminated at the colon. End pointer I need a base 10. And the idea is if arrival is unset, then arrival equals the value. Else if it's the runtime that's unset, then it's the runtime that equals the value. else if it's the IO period that's unset, and then it's the IO period that equals value. Else, there's some weird stuff that's happened. Else, fprintf weird jobs input extra colon, and this is pass input jobs, and this is MLFQ. Okay. And then head, after we do this, head should now point past the C pointer, and because I get nervous, I'll reset this to be the colon again. Else if C is a comma, then that indicates that we've sort of hit the end of, actually, if I hit the IO period in this case, that means I know I should have read in all the information, right? So maybe it's better to just do this here. I don't know, actually. Can I be like IO period equals this value, and then jobs at what's the index called? Num jobs equals, does this not work? Okay, fair enough. ID equals num jobs, jobs at num jobs dot arrival time equals arrival. What's wrong with this? Expression must be a modifiable L value. I guess the const thing isn't right. I thought I could set it to whatever I wanted, but I guess not. Okay, where else do I use const? Yeah, I think this is gonna fail on me. I thought that's how it worked, but I guess I misremember. Right. I'll read through it. I know const is like, you can't reset the value. But how do you set it in the first place then? I guess you can't. I don't know. Like, I know it means, like, const means you can't write to that field anymore, or write to that bit of data. But I don't know, I figured that for a struct, like, if it hadn't been set yet, but I guess not. Num jobs dot CPU runtime equals runtime, and jobs num jobs dot IO period equals IO period. And then everything gets on set again. Well, maybe I won't, because in case you do make an extra colon, I want to make sure everything else is set, so that I will reset it. I will say head equals C plus 1, because now the head should point past the comma. Sorry, yeah, the comma, and then unset, and then make everything unset again, I think is my big plan. And hopefully that's fine. I don't know if I've done anything wrong there, but I think I'm good. Int arrival, I have to make sure I increment num jobs when I'm done with it. So how would I do this generically? Because, like, what if you have, like, a bunch of fields that you have to read in? Do you have to, like, do it like this? Like, this feels sort of stupid. You probably would have, like, an array to represent the particular input, where each slot is a field that your input refers to, and then you'd have an index that you are pointing, that points to the next field. And every time you fill in a field, the index moves along, and then the next time you read in would be associated with that, and you keep doing. I think that would be, yeah, that would be more generic and easy. But for this, it should be fine. For 3 fields, I don't think that's worth it. Okay. hopefully that's fine. So yeah, in terms of thinking about it, this input should have numbers, colons, or commas. If it's a number, I should ignore it. If it's a colon, I should read in the number between the head and the colon, which is being signified by an alternator, and then reset to a colon. But yeah, so when I do this function, it will read from the head to this null terminator, which is actually a colon, and then read in the number, set the number correctly, fill in the job, right? Like fill in the fields correctly, increment num jobs, and then if it's a comma, move head, make sure head is pointing past the colon afterwards. If it's a comma, same kind of thing, mark it all as unset, and head should go past the comma, and C will also move to meet that head. And then yeah, I think that's fine. And then return num jobs. Good. So we do that. And then we do something like, so we've done that. We have our jobs array. We've managed to get the values from this. Should I just I'll just print the, I'll make a function called print job, given a job. And IO period. Given the job's ID, the job's arrival, the job's CPU runtime, and the job's IO period. I missed. And then, so I'll just quickly say, do all this, and then for int I equals 0, I less than num jobs, print job given the address of the jobs at index I. Okay, so if I do, there's a few things, this is still gonna be a bit weird. Alright, let me just not bother with the proper thing. What do I need? clang, I'll say dash G fsanitizer equals address, and then dash I. I have a bunch of things I have to include. Not a bunch. One. I should have it here. I think it's this. Cargparser. Okay, I'll probably cut this out because I don't want to just expose my entire file system. Okay, so I have the include, and then I also have to compile the actual C files, which hopefully is just this. And then also I have to compile the mlfq.c. That should be good. Okay, so if I close this now, and I do gmod +x, compile. Oh, I'm in the wrong thing. Gmod plus x compile. I'm in the wrong thing still. cd ml. Okay, gmod plus x compile. Not sanitizer, sorry. String hashing.h not found. Because why? I could have sworn they're both in the same place. They are not. They are not. ls. Where is string hashing actually? I don't remember where it is. Ah, of course. I had it in the CARG pass, but it was a different directory because I didn't want it to be there. Okay. Let's take 2. Or it's just the const part. I would hope. Otherwise, I'm not very sure. Okay, good. True. Jobs. So yeah, let's say I give 3 jobs. I've got like 3:4. So arrival of 0, runtime of 10, IO of 4. And then another job is like it arrives at 2. It has to run for 12 seconds, and it has an IO of 5. And one which is like 6. It runs for 15, and it's an IO of 3. Yep. And then what else? Well, everything else is optional, isn't it? So I can test my. Oh yeah, I did something weird. Good, my error checking worked. 0 done done comma done comma. Yep. Oh, maybe my error checking worked too well. 0 10 4. Why has that happened? Maybe I'll, instead of looping, hang on, let me just call this print job thing as I go. Address of jobs at numjobs. Let me compile. Oh. What? Did I do it twice? Did I not cut it? I just copied it. Hold on. Okay. Arrival 0, runtime 10, IO period 2. It says 2. What? Oh, I'm dumb. No, yeah, you can't do it like this. Yeah. Okay, so yeah, no, I'm silly. Okay. So basically, you have to do one more read. I forgot. So basically, you have to do the same trick, and they have to be like, if runtime is not equal to unset, then something really weird's happened, because the thing before a comma is meant to be the runtime. So do something like this. Seen a comma, but runtime is already set. Otherwise, you can go Bing, you can say runtime is equal to bong, and then you can be like, oh, I shouldn't have deleted that, actually, I needed that. Jobs at numjobs dot id equals numjobs, jobs at numjobs dot arrival time equals arrival, jobs at numjobs dot runtime is equal to runtime. Wait, runtime or no, not runtime, sorry. This should be the IO period. Look at me being silly. And then jobs at numjobs dot io is equal to IO. What? I missed. And then we can decrement in the last case. Okay, if I try that again, will it be nicer to me? No. Fantastic. What? Maybe I'm just hungry. Did I not do this correctly? We're going through all the input. Start at 0. If it's a colon, then we get the value. We set the colon to 0 and we get the value. If arrival is unset, then we make this. Arrival equals value. Else if it's the runtime that's unset, then runtime equals the value. Else, what else could possibly be happening? Let me let's just see where we get up to before it errors. 0 colon 110 colon 4 comma 2. Did I not? I said int. I do that from time to time. I just randomly redeclare things for no reason. Whoa. Really? Ah, of course. No. Wait, what happened? Let me check one thing. If I put a comma at the end, no, it doesn't. Okay. 6:15:3. Okay, so I think what might be happening. Let me get rid of all of this. Before it only printed out 2, right? So that's another issue I need to deal with. But this time we got all 3 and then broke. Let me just. Wait, sorry. Compile it again and then go. Oh. Interesting. Is it. So it's part of the. What? Excuse me? Oh, it's part of the freeing. Oh, that's not good. Oh, no. So bus, this fault was caused by dereference of a high value address. Oh, no, I thought my freeing was good. Disassemble the provided DC to the PC, so yeah, it's this thing again. Oh, you're joking. I've used this before for a few things, hasn't done me wrong any time yet. Interesting. What if I do undefined or something? What? Oh man. So specifically the address. For now, I'll just leave it because it's not my main focus. Really shouldn't be how I deal with these problems, but I really don't want to get stuck on stuff like this right now. I'd rather sort of see other stuff working. Okay, so you got that accurately, right? 2, 12, 5, 6, 15, 3. Okay, and the thing I have to do is, so the way I do this is I would have like half finished, because what's happening is false. What's happening is if I put the comma at the end, then it because like it waits for a comma to be actually create the job process. If I don't have a comma on the end, the very last job 2 doesn't get read in, right? Job 0, job 1 got read in, but job 2, its values got read in, but these lines didn't run. So basically, if I hit a comma, then half finished equals false. We got it done fully. If we hit a colon, then half finished equals true. And the idea is, if half finished, then basically, I think you run this. Maybe this, I guess this should be its own function, which is fair enough, but for now, I'm cool if I just, maybe I will make a function. So void initialize job, given the address of a job. What the heck did I just do? mlfq job star job, and given arrival, given runtime, given IO period. The idea is job, oh, and given its ID actually. Job ID equals ID, job arrival time equals arrival, job CPU runtime equals runtime, job IO equals IO. Messed up. I didn't mean to do that. What have I done? Oh my god. What is happening? Okay, this isn't working. I was gonna do a thing where I like. Okay. There you go. Okay. I don't know. That didn't really work the way I thought it would. Okay, so if instead of doing this, I do initialize job given the address, which would be jobs, num jobs, and then giving its address, and then giving arrival, runtime, and IO period. Did you work? Ah, and the ID, of course. Num jobs. Oh, I deleted the. You good? Okay, and then instead of doing, what the heck? Okay, and then instead of doing the slab, we can just replace it with that. Okay, let's try that again. Did I not do the thing? What? That's not good. I guess I didn't work. Huh, I'm surprised. I would have thought that would be fine. I'm giving the address of that particular spot on the array, so then surely when I access it, it would write it no problem. Right, or no? Okay, wait, let me revert back to poorer practices. Huh. Ah, because I know why. I know why. I never incremented num jobs. Uh, I don't actually know if it's safe to increment like within the... This will work. I have full faith that this will work. Compile one more time, run it one more time. There we go. Okay, fantastic. So we have an ability to pass the jobs, which is great. And then we need to also do other things. Construct the MLF queue structure. It's 10 p.m. Fantastic. I guess I do this all on the... Oh, I can maybe do this on the stack, surely. I just have to make sure I... it's probably easier on the heap, but let me try. MLFQ. So I have the overarching structure, and then I need some queues. Highest non-empty queue is null. Num queues, all these values are given by the command line arguments. That's easy. All the queues is just... Okay, yeah, I'm pretty sure if I just say MLFQ dot all queues is equal to MLFQ... hang on. All queues given the number of queues. It's an array of MLFQ pointers, which is exactly what I want. So this guy is set to that guy. So this is on the stack, you are on the stack. And then what else? The values, right? Highest non-empty queue should be null. No need for you to point to anything yet. And then MLFQ dot num jobs equals the num jobs. No, it's equal to 0. This is different. This is the number of jobs actually on the system. Where's my part? Oh, there it is. And then MLFQ dot time till boost is equal to the boost. MLFQ dot between boost duration I've done that. Number of queues I've done, right? Maybe not. I've done that. Num queues I've done, num jobs I've done, highest non-empty queue. Between boost duration and all. Okay, so I've done everything for that. Now I have to actually make the queue objects, the MLF queue, like these guys. This I'm less confident that I can do on the stack, because if I do it within a for loop, going, number of queues, if I do it within a for loop, then I'm pretty sure they all get erased by the time I go outside the for loop scope, right? Or I won't be able to reference... Oh, no, I think I'm okay, actually, because the lifetime of the function is still... Oh, I don't know how this works. If I create variables in the for loop, and then I go outside the for loop, do those variables get wiped? I should know this, but I've forgotten. Nah, but I think it'll be okay, because I think... Oh, I'm really not sure. I don't think they get wiped. Okay, let's just try it. For int I equals 0, I is less than the num queues, plus I, right? We're going to say MLFQQ, MLFQQ, MLFQQ dot allotment is equal to allotment. This is from the user input. mlf q dot priority value is equal to I, right? Because it's the index thing. mlf q dot time slice is equal to the time slice value. Make this the same. But yeah, that's fine. mlf q dot, sorry, underscore 1 to q is empty. Null. Nothing there. Wait, should it be empty? Now I'm a bit confused. Ah. I really think I should just use the heap. I don't know what I'm doing. Empty queues across the board. Like, I'm creating these things within a for loop. So once I go outside the for loop, I won't be able to access like these particular variables. I can access them through, like, sorry, hang on, let me finish this. And then, so I've made mlf I've done all the fields, right? Allotment is done, priority value is done, time slice value is done, q. So I've made the mlf and then I just have to be like, mlf all queues, which I have set to something, to be this space, at index I is equal to the address of mlf right? So once I jump out of here, of course, this guy, I can't access these variables directly because they're within this particular scope, but I think their information doesn't get wiped until the actual main function gets destroyed, right? Like until that stack frame is gone. I think it's fine. I don't actually know. Okay, and then, after it's all said and done, we say simulate mlf we give the jobs array, we give the num jobs, and we give the address of the mlf. I should just use the heap. I don't know why I did all this. I'm pretty sure this is going to break. I don't think this will work. Stack, yeah, there you go. Stack use after scope. Yeah. I'm pretty sure that's because I tried to use the stack too much. After, like, the error name even just matches what I was worried about. So you really just can't use the stack for things like this? Like, surely there must be a way, right? But I mean, I'd have to use a... Wait. Hang on. No, of course you can do this. Hang on. You just shouldn't make variables, I think. I don't know, actually. Alright, let me use the heap. So... I don't actually have to comment this out. I can just say user pointer equals malloc size of mlf q, and then go bang, bang, bang. Then I can make a queue equals malloc size of q, your Q is equal to this Q. In fact, you're kind of a middleman. I can just do that. Okay. So bang, 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 bang. And then, yeah, I think I'd prefer to have a variable there. And then I don't need the address. I can do that. Okay, so these guys that I'm accessing will be on the heap. So hopefully that will fix everything. Unless, or not. Oh, okay, never mind. Current running. Current running refers to, I thought current running referred to a, but job is, is it because job is on the stack? Stack use after scope on this particular address? Okay, I was gonna stop, but I'm proud of myself because I actually read through the error message and I understood what was happening. The stack issue has nothing to do with all of this nonsense, although this is ugly. It has everything to do with the fact that I create this guy in my main simulation function. I create when I check for something that arrived, I create this, which is equal to this, but because these guys aren't addresses, I think this is like a full-on copy. And because this is like within this scope, this if statement scope, when I try to reference, when I give the arrived job and add it to the queue, once this if statement like finishes, this guy gets wiped, I guess. So yeah, I guess once you leave a scope, not necessarily a function scope, even like a statement scope, the variables that you were using in here get wiped. I don't know if I knew that. Maybe I should have, but I knew that for functions. I don't know if I realized that for statements. But anyway, so once this gets wiped, this address is no longer valid because the arrived job is no longer valid. So when I try to access the jobs in the MLFQ queues, it wipes. It doesn't work. I think this is my hope. So what I'll do is I'll access the address of this guy, and I won't do this. And so I'm accessing this guy's address and storing it in here. And this guy was made on the stack way before. Like this guy is well within scope. Right? This is I went too far back. Where am I? This guy is a function parameter. So like that guy's in scope for sure. So hopefully I've lost everything. Hopefully this will work. I haven't actually tested this. I'm looking at the error message. I just truly believe. Oh wait, hang on. I need to put back the sanitizer. Although that's not good either. That is seg faulted. Wait, to work? Oh. We have a big problem. Okay. That's a job for the debugger though. But I think I fixed it. It makes sense. It makes sense.